Hi, I'm Sparrow, and I'm a science communicator with a background in behavioral science and pedagogy, which is the science of education. This week's topic is a journey to the center of the universe, and I'll be covering the history of how humans have considered the universe to basically work. Let's jump in. To start with, I have copious notes because we're covering hundreds of years of science here in one short video, hopefully short. I put together a timeline of what people have believed and approximately when those beliefs changed. After I go over the timeline, I'll dig into each of the big universe beliefs that people have had and the big names of people involved in formulating those beliefs and what that means for us today. So here we go. Let's jump into our little journey. At the beginning of time, humans believed the Earth was flat, and that lasted until around 600 years before the current era, or if you are religious of one of the Abrahamic religions, 600 BC. From about 600 BC or 600 BCE onwards, people have mostly believed that the Earth is a globe or a spheroid, similar to a sphere but not exactly perfect. Around 150 years into the current era, or 150 AD, geocentrism was born, and that lasted all the way up until the 1600s. From there, humans began to believe in something called heliocentrism, which was a belief that the sun was the center of the universe rather than the earth. That lasted until 1785, at which point people adopted galactocentrism, a belief that the Milky Way galaxy was the center of the universe. And in the 1920s, galactocentrism was proven wrong, and humans adopted acentrism, also known as the Big Bang Theory. So, let's look into what geocentrism is. Most simply, geocentrism is the idea that the Earth is a sphere or a spheroid, and that it is also the center of the universe, meaning that all of the stars, the sun, and all of the planets rotate around the Earth. The biggest name in geocentrism is Ptolemy. Yes, like the pharaoh. Ptolemy built a 3D model of how he believed the Earth and the entire universe worked. And this model included the sun, the moon, and the 5 known planets of the time, which of course are Mercury, Venus, Mars, Jupiter, and Saturn. His 3D model close to accurately showed where these things would be if you're looking at them with the naked eye in the sky. Based on the level of observation people were capable of at the time, this 3D model worked. It looked right. He also came up with a system for mathematically predicting where celestial bodies would be and where to look at the sky and find them, which was known as Ptolemaic system, as the Ptolemaic system. His final big contribution was the idea of epicycles, which I had to look up because I'd never heard of it before. But currently, we think of an orbit as you have the thing in the middle and you have the thing orbiting around it. But because this didn't quite work for a geocentric model, Ptolemy had to find a way to explain why things didn't show up exactly where they should. And what he came up with was this idea of epicycles, where you have your central object, or Earth, you have a circle around it, and then you have objects circling the outline of that circle, basically, as they travel. And using his idea of epicycles, he was able to pretty closely predict where to look for something in the night sky. And so his model was used all the way until the 1600s. That actually makes it the longest lasting model of what our universe is like ever to exist. It spread during something called the Islamic Golden Age. Basically, in the 8th through 13th centuries, Islam was on the rise across all of the Middle East, Eastern Asia, Northern Africa, and Western Europe. And with the expansion of Islam came a major exchange of ideas between all of the peoples of these regions as more and more people were traveling. At this time, the prevailing ideology within Islam was that it was the duty of Muslims to study and learn as much as possible about Allah's creations. And so they did. And this era was known for a major rise in medical discoveries, mechanical inventions, philosophical ideas, and all other forms of science. And as I was looking more into the Islamic Golden Age, I found a few things that I thought were just pretty cool that I wanted to share that were sort of invented or discovered during that time. The first being coffee. Everybody drinks coffee now, just about. I personally don't, but basically everyone I know of enjoys coffee, and we have coffee because of the Islamic Golden Age. Another really cool discovery was optics. I wear contact lenses, which correct the way my misshapen eyes struggle to deal with light. And that's possible because of discoveries made during the Islamic Golden Age with regards to how our eyes process light and how colors are made out of light. And the last thing I found that was pretty cool is we all know about the Wright brothers, but not as many of us know about, and I hope I'm saying the name correctly, Abbas ibn Firnas, who created a functional mechanical flying machine based off of his own improvements on Da Vinci's drawings. It's very cool. However, in the 1600s, we stopped believing in geocentrism and adopted heliocentrism. Heliocentrism is the idea that our sun, Sol, or Helios, is the center of the universe. And the three big names of heliocentrism are Copernicus, Galileo, and Kepler. Copernicus is famous. He's the guy who said, hey, our Earth goes around our sun. And so does probably everything else. We know he was right about Earth circling the sun. We also know he was wrong about everything else doing it. But he dramatically changed how we viewed the universe. Building on his ideas was Galileo. He discovered that the Milky Way was not just a cool sky blur, it was made out of stars. He also discovered that the rest of our planets were like Earth and did circle the sun. But he noticed that Jupiter is like Earth because it has moons. He was only able to observe 4 of Jupiter's moons, but his observation went pretty far to saying, well, not everything orbits the sun exactly, because these things orbit Jupiter. He invented a form of math called kinematics, which we actually still use today. Kinematics is the math used to predict where a moving object will be without asking why it's going there. Lastly, we have Kepler. And if you haven't heard of Kepler, I don't know why, because we still use Kepler's 3 laws. The first law regards orbits. Kepler noticed that planets don't orbit in a perfect circle the way people before him believed they would. Instead, they orbit in something called an ellipses, or an elliptical orbit, which is basically an oval. It's not a perfect oval, but it's good enough for you and me. His second law stated that planets in an elliptical orbit will move faster as they get closer to the sun and slower as they get farther away. And his third law delineated all the math and geometry involved in predicting the exact speed any specific planet will be going at any particular point in their orbit. And like I said, we still use his discoveries to this day. Like everything else, though, heliocentrism fell aside as more information became available. In 1785, galactocentrism was born. The idea behind galactocentrism is that our galaxy, the Milky Way, has a center, which is the center of the entire universe. And there were a few variations on that. The first being that our sun was the center of our galaxy, and therefore, technically, heliocentrism's right. Wrong. The second being that the galaxy had its own central sun, which was the center of the universe. Well, we now know that's also not the case. And the third idea was that the galaxy does not have a central sun, but is still the center of the universe. And that's closer to true, while still being not the case. One of the big tenets of galactocentrism was that there wasn't actually anything outside of the Milky Way. And that is the most non-true thing about galactocentrism. Some big names in galactocentrism were Herschel and Bessel, who both made observations about the Milky Way and studied its motion and contributed to formulating this belief, as well as Thomas Wright and Immanuel Kant, which, if you're interested in philosophy, you've heard of Immanuel Kant. He's famous for coming up with something called the categorical imperative, which describes the way humans have an instinct to decide that something is good or bad. Well, he was also involved in some space stuff, which was a surprise to me. But both he and Wright made observations of celestial bodies outside of the Milky Way galaxy, including nebulas or nebulae and other galaxies, which they decided must be additional universes, or as they called them, island universes. They floated this idea with the scientific community, and the scientific community was like, no, you're stupid, there's nothing outside the Milky Way. Everything changed, however, in 1913. And just as an aside, I would like everyone to comment whether or not they have heard of a woman called Henrietta Leavitt. She's kind of a big deal, and I'd never heard of her before, which is really weird. But in 1913, Henrietta created something called the Standard Candle. Basically what it is a very complex system of math that we can use to determine exactly how far away a celestial body, or specifically a star, is from an observer based only on its light. And this is like the coolest thing, and at the time it revolutionized everything in science, and it continues to be a foundation of how we do astronomical science to this day. Prior to this, people sort of made their best guesses based on what they knew of geometry, where other celestial bodies were, and kind of how big it was to their view through a telescope or with their eye. And that was not accurate. In fact, they were all convinced that there was nothing outside of the Milky Way because of their flawed ways of calculating distance. However, using Henrietta Leavitt's Standard Candle, Shapley was able to prove that the Milky Way didn't have a central sun. And Hubble was able to prove that things existed outside of the Milky Way. And in the 1920s, acentrism was born. Acentrism, or the Big Bang, is this idea that the universe is everything. It's universal. And it's expanding and growing from in every direction without having a center. And it's kind of hard to like picture it in your head, right? Because like if I expand my fingers out from the center of my fist, there's a center. But if I do this with both hands, there's not a center for all of these things, right? And that's kind of that idea that every individual system, our solar system, is expanding. The moon is getting farther from the Earth. The sun is spreading from the center of the Milky Way galaxy. The Milky Way is spreading out from the whatever it circles, and so on and so forth. And this is observable, and more importantly, using Leavitt's standard candle, it's measurable and quantifiable. Looking at all of this, Hubble proved stuff exists outside the Milky Way, things are growing, and we can calculate it. And so he floated this idea of acentrism. And in the process of making additional observations to support his idea, he discovered something pretty cool called redshifting. Now, if you'll recall, when we were talking about the Islamic Golden Age, we talked about optics and how eyes observe light and color. If you think of light waves as being a spring, things like violet and blue are a very tightly wound spring. It's very short, it's very tightly coiled. Whereas the color red is a very spread out string. So if you take that same spring and you just stretch it as far as it'll go, it's going to turn into the color red. And what Hubble discovered was that you can additionally measure how long a certain celestial body has been around by the amount of redshifting of its light, which is just crazy cool to me. And in all of his theorizing, and the reason that the Big Bang or acentrism is called a theory and not just an idea like the others is he made a prediction. He predicted something called cosmic background microwaves. And he said, well, if I'm right about all of this, then at some point we should be able to measure these CBM waves. And there wasn't a way to measure it at that time, but he said this is something that should exist if the rest of this stuff is true. And in 1964, we did it. We measured cosmic background microwave radiation. And that took the idea of acentrism or the Big Bang from being just another best guess idea to a theory. Because in science terms, a theory organizes known data and predicts future data. That takes us to the end of our journey to the center of the universe and our discovery that it doesn't have one, as far as we know. And I wanted to leave you with this. Throughout all of these stages and throughout the last, a bit over 2,000 years of science that we just rushed through in about 18 minutes, what we saw wasn't idiots being dumb. What we saw was people making their best guesses and best efforts at understanding the universe based on what they could observe with the tools they had available. And at each stage of change, we saw people building on the ideas that others before them had had. And so, I want to leave you with this thought. We currently accept the Big Bang or acentrism as an accurate model of our universe. But that can change as more scientific discoveries get made and our technology for observing the universe improves. It is not only possible, but highly likely and virtually inevitable that someday what we know about the universe will be proven wrong and we'll learn something that people today can't even imagine. So with that, thank you all for tuning in. Please like, subscribe, and leave a comment. See you next time.